Hello, today we will be working on an FRQ. For part A, it asks how much water will be in the tank A at time t equals 4.5 hours. The graph above shows us how many liters are being added into tank A and tank B per hour. Therefore, in order to find how much water will be in tank A at time t equals 4.5 hours, we are going to integrate the function from 0 to 4.5. Function A is already given to us in the problem, so we're going to use the function given and integrate it from 0 to 4.5 using a calculator, which should give us 66.532 liters of water. For part B, there are two things you'll need to find. First, you'll need to find what K is, and using the value, you'll find the difference between the amount of water in tank A and the amount of water in tank B at time t equals K. Notice at t equals K, both of the functions A and B intersect. Since they intersect, it indicates that the rate at which the water is flowing into the tanks are the same. Since B has a constant rate of 20.5 at that time, we'll set function A equal to 20.5 and solve for K. Using a calculator, this should give us T, or K, equals to 0.892 hours. Using this value, we'll find the difference between the amount of water in tank A and the amount of water in tank B. To find the difference, you'll need to integrate 20.5 minus function A from 0 to K, which is equal to 0.892. You'll put this into the calculator, which would result in 10.599 liters as the difference between the two tanks. For part C, you'll need to find how much water is in tank B from K hours to 2.416 hours by integrating the function B over that interval. Since we solved for K in part B, we already know that it is equal to 0.892. However, since we do not know what the function B is, we'll have to subtract 14.470, which is given to us and is the region bounded by the graphs of function A and B over the interval 0.892 to 2.416 from the area of function A in that same interval, which, if you put it into the calculator, it should equal 30.028. Next, you'll need to find how much water is in tank B from 0 to 0.892 hours. From part B, we already know that water is flowing into tank B at a constant rate of 20.5. It is linear. Therefore, we are going to integrate 20.5 from 0 to 0.892 and add it to the amount of water in tank B from times t equals 0.0892 to 2.416, as previously found, which is 30.028. When integrating 20.5 from 0 to 0.892, it would be equal to 20.5 times 0.892 minus 20.5 times 0. Once we add these together, the amount of water at time t equals 2.416 in tank B is equal to 48.314 liters of water. For part D, you are given the function for the rate at which water flows into tank B, which is modeled by function W. In order to find out if the difference between function W and function A is increasing or decreasing at time t equals 3.5 hours, you'll have to find the derivative of the function W minus the function A. In order to do this, you'll need to find the derivative of function W and function A separately, which I've shown at the top. We can differentiate function W by using the power rule and the product rule of finding derivatives, and we can differentiate function A by using the chain rule and the power rule of finding derivatives. Next, you'll replace t in both derivatives with 3.5 and solve in the calculator. The derivative of function W at 3.5 would equal to negative 3.786, and the derivative of function A at 3.5 would be negative 2.643. You'll subtract those values, which will give you negative 1.143. Since the derivative is negative, it indicates that the difference between the two functions are decreasing. If it were positive, the difference between the two functions would be increasing.